Hello, and welcome to this seminar titled Safety Applications Using a Programmable Safety Relay. My name's John Burns, an application consultant for the Electrical Products Group here at Siemens, and I'll be your host for today's seminar. The agenda for today's seminar is broken into 4 different areas. First, titled The Road to Machine Safety. In this area, we'll go through the different safety standards that are recognized here in the U.S. In the second part, Making a Safe Machine, is where we'll apply a safe process or discuss the safe process for applying safety onto a machine. In the third area, we'll actually review some of the hardware and software choices that are available from Siemens to be used on your machine. And then lastly, we'll work specifically with one of our programmable safety relays and use software to configure it for different applications similar to ones on our machines. So let's get started. So with the road to machine safety, we'll first focus on the value of workplace safety. And that particularly is the protection of people, machinery, and the environment. But of these 3, the one we're going to focus on mostly today is the protection of people. In order to show how important it is to protect people around machinery, we went to the U.S. Bureau of Labor Statistics to gather some data. What we found was that over 1,000 workplace fatalities happen each year, and that 2/3 of those fatalities are due to contact with equipment or other objects. That means something that runs into them or they run into something. Additionally to these fatalities, there's also over 690,000 injuries that also happen each year. So now you start to get a picture of why it's so important to be able to add machine safety to be able to try and reduce some of these injuries or deaths. The global standards imposed by the European Union, or EU, have their basic equivalent regulations also in North America. These are the standards to which machine builders are typically designing their machines to, and these have been around since about 2005 or 2006. According to all revised and new machine safety standards, including the Machinery Directive in Europe and the ANSI, NFPA, and other standards in the U.S., a risk assessment must be performed now by the machine builder. This is no longer an option. The risk assessment is an important part of the safety process that we're going to discuss here in a little bit. But again, according to the Machinery Directive and the associated U.S. standards, this action is no longer optional, but now mandatory. Let's take a look at a machine that has some obvious hazards. This is a cutting machine, and you could consider it a bit of an elaborate table saw. So first, let's take a look at some of the hazards that are present on the machine, such as some clamping plates, the cutting disc itself, maybe some transport rollers on the exit, as well as maybe chips or debris from the cutting. So all of these different hazards have different potential injuries associated with them and specific risks. It's important to understand the difference between a hazard and a risk. A hazard is something inherent in the machine that can cause injury. A risk, on the other hand, is the potential for injury of a particular hazard. That spinning blade, for instance, here is an obvious hazard. But nobody can reach it, then the risk of being injured by it is minimized. It's important to understand that each of the risks on this machine have to be assessed separately. Being cut by the spinning blade, for instance, presents a different risk than being pinched by the clamps at the feed end of the machine. We're now going to move into the second topic for today's seminar, namely making a safe machine. Here we're going to focus on the safety chain process that we talked about earlier, which is made up of 3 main areas: the risk assessment, risk reduction, and then proof. The first step is the risk assessment. During the risk assessment, the machine builder first describes the machine and its function, then identifies the hazards on the machine and evaluates the risk posed by each of these hazards. This is what we did earlier on that slide, looking at the different parts of the machine. So let's now move into the risk reduction phase. During risk reduction, for each of the risks on the machine builder has to define safety measures, design safety functions, and then implement the safety concept for the machine, and then put them into operation. So now let's take a look at how that's accomplished. As we take a closer look into the area of risk reduction, here it's typically broken into three different areas. The first being what they call mechanical design measures. Here, a lot of times it's happening during the construction of the machine, where you may be adding some mechanical guarding or fences around the machine, again, to try and reduce the risk of injury. On some machines, this may be all that's needed to get that risk to an acceptable level. But on machines where mechanical guarding is not enough, you then implement the second level of operation, which is now technical measures. Here is where you'll apply technology to further reduce that risk down to an acceptable level. The third phase, which is operational measures, refers to now maybe adding labels or simply training the personnel that are going to be around that machine of the inherent risks. Again, all three of these are equally important. So don't disregard the importance of simply either adding labels to the machine or providing training on the machine. Again, just because you know that saw blade is sharp with lots of teeth and could potentially have a great risk of injury, it's just as important to be able to train that operator and make him aware of that danger as well. So now let's focus on the third part of the safety process chain, which is the proof area. No matter the system nor the measures implemented, the machine builder is now required to provide proof that they've taken the appropriate safety measures for their machine. The way that's accomplished is through thorough documentation of the measures taken, a validation procedure that proves that the system works as designed, and then finally, through documentation of the validation results. So now that we've looked briefly at all three parts that make up the safety process chain, let's take a deeper dive look into the part called technical measures. Again, here is where risk reduction is by the use of technical safety devices and safety components, which is referred to also as indirect safety. When we talk about these safety functions or technical measures, we're really talking about the safety relevant part of the control system, which includes three main components: detection, evaluation, and reaction. In the detection phase, this is where monitoring of conditions on and around the machine can be accomplished by way of an e-stop, gate switch, safety mat, or possibly maybe a light curtain, for example. All detection is wrapped around detecting the hazardous situation. The second component is the evaluation piece. In the evaluation piece, this is where different components such as safety relays, programmable safety relays, or safe PLCs have the ability to do safety-based logic. These components will take inputs from the detection phase, apply safe logic to those inputs, and then, based on programming or logical functions, will then decide in the reaction phase whether to remove power from the machine. The third and final component of the safety function is referred to as reaction. In the reaction part, this is described by the action of removing the hazardous motion or process, either by coming to a safe speed, managing the process variable like level or flow, or etc., or by simply shutting down all or a portion of the motors associated with the machine. Thus, the safety control system is created. We have inputs to sensed conditions, logic that drives the operation and monitors the safe function on the machine, and then some type of outputs that control the motion or force that the machine uses to fulfill its desired purpose. In conclusion of our review of the safety function or technical measures needed to be put on a machine, whether it's the detection phase, the evaluation phase, or the reaction phase, Siemens offers a complete portfolio of solutions for your safety needs. So now let's take a closer look in the evaluation phase, in particular to our safety relay portfolio. So let's now go through a simple overview of our 3SK safety relay family from Siemens and showcase some of the benefits that it can provide. To start with, we have a line called the 3SK1 standard system. With the standard system, this is a good application where you have maybe minimal safety inputs, but in addition to the outputs on board the base unit, you can also now have output expansions to be able to switch multiple voltage levels or perhaps higher amp capacities on your outputs. The next one is our 3SK Advanced series. Here, you'll have a little bit more flexibility with the system to have both instantaneous or delayed outputs, as well as the outputs and the base system can take advantage of something called a device connector. This provides a pop-in type shoe that the modules will slip into and provide a backplane connection between the host base unit and the output expansions. Device connectors greatly reduce your field wiring that normally on outputs would have to be daisy chained from component to component. On the input side, 3SK1 now is also expandable. Again, with the optional device connectors to reduce wiring, you can now add additional safe inputs to the system. Also, an optional 120 volt power supply is also available on the system. Programming of the 3SK1 Advanced is completely done using dip switches. The third component is our 3SK2 line. This is where we get into programmability with the safety relay family. Here we offer two main base units, one that has 10 single channel fail-safe inputs and 2 fail-safe outputs, or a wider one which has 20 fail-safe inputs and 4 safe outputs. Again, this is a programmable system, so there is a software configuration tool that comes along with it, and this is what's being used to be able to provide, say, zone control, where the 3SK1 series basically is a single zone type component. The 3SK2 series, you can now, using software, decide whether you want to shut off maybe the entire machine versus only different areas of the machine. The 3SK2 series also supports an operator display for diagnostic functions, as well as communications with our Profinet field bus system. Now that we've gone through the hardware family for the 3SK2 safety relays, let's focus more specifically on the hardware we're going to use moving forward for our workshop hands-on applications. So pictured here is our 3SK2 demo case, and on the case we have a 3SK2 safety relay as the main logic evaluation unit. To the right of that are 2 output expansion cards. One of your typical output expansions you would see for a safety relay, but to the right of that is now a full fail-safe rated reversing motor starter, which is our 3RM1 family. Those outputs then feed these 2 indicator spinner lights to indicate motor rotation. And for a standard output, we also have a signaling output from the 3SK series, and that's what this amber lamp is here that we can use from a signaling standpoint. On the inputs, we have a safe input in view of a e-stop switch on top of the demo. In addition to that, an RFID safety switch that slides open and closed, a safety actuator switch also for door applications, And then lastly, 2 buttons to simulate 2-hand control processes. On standard inputs, we have a reset button, a right and left selector switch for our reversing starter, an RFID key switch for selecting modes of operation as well. So here you can see from this demo case we can simulate a number of different safety circuits in lieu of all of these options. So now let's take a look at the software that is required for configuring the 3SK2 series. So I've opened up here this safety configuration software for the 3SK2 relays, referred to as Safety ES. Let's go through the different parts of the software as we have in front of us. To start with, up on the top, we have a menu and toolbar where you can easily access different functions of the software. Secondly, on the left-hand side, we have what we call the navigation window. This is where you can select the various views of your open project, and what you choose in the navigation window then appears in the center in what we call the workspace. Here's where you can edit different components of your configuration. Below that is our output window. This contains different information on the project, specifically to what's being shown in the workspace. On the right-hand side, we have what we call our catalog window. Here we list all the different hardware components that are available for the 3SK2 series. Below that, we have our description window, which contains information on what you've selected up in the catalog window. And then lastly, you have the status bar down on the bottom, as well as you can always press F1 to get online help for the software. So let's get into our actual first application for our hands-on workshop. In the hands-on workshop, we're going to do 3 different exercises that are all going to build from the previous exercise before it. In this first exercise, we're going to do a simple e-stop driving into the 3SK2 base unit, the evaluation unit, and then one of the safe outputs from the 3SK2 is going to drive the spinning wheel. So you can see that on the slide here as far as the components that are going to be affected here. Again, with an e-stop, it's required by code to have a manual reset button in order to restore power to the machine. So that's what the blue button is there for. The software to represent this logic in our Safety ES software is going to look like this, where we have that e-stop component being driven by the e-stop, the blue reset button, and then the output directly from an output from the 3SK2 base unit to that spinner light. In exercise number 2, what we're going to do now is add a protective door function. So what we're going to do is we're going to use the RFID key switch or RFID door switch here as an additional device, and now add that to our software from the original configuration. In lab exercise number 3, we now add some additional components, that being the additional door switch that we have, the interlock switch. But now the output, rather than using a safe output directly off of the 3SK2, we're going to do the 3RM1 motor starter, and that motor starter is then going to drive the second spinning wheel. And that logic is going to look like this. So again, 3 different exercises, each building from the previous. So let's open up the Safety ES software and start doing the configuration. So here we are with the Safety ES software, and I've created a starter project for us to get us going. So far, I've inserted a 45mm 3SK2 safety relay into the hardware list. Now, if I double click on this, we can open up the properties for the safety relay. But if I right click on it, we can open up what we call terminal identifiers. And what this is associated tag names with the actual input and output connections for the safety relay. So what I've done to make things easier for us when we do our configuration is I've actually put in tag names for what devices are connected to those actual inputs, so that I don't have to remember what's tied to input 1 or 2 or 4 or 5. I can just look at the tag names. So it'll make us a lot easier when we're doing our configuration. You'll see that in a couple of minutes. So for this first exercise, it's a fairly simple circuit where we had the single e-stop with a monitored start for a reset, triggering basically a dual output triggering to run the first spinner wheel. So if I come to my diagram section here on the left-hand side, you'll notice in the center, this is my working area where I'm going to start creating my software configuration or safety configuration. So the first thing I want to add is that e-stop function. So if I come onto the right-hand side tree and open up monitoring functions, you'll see an e-stop. So I'm going to drag that over onto my screen. And now to open up the properties for the e-stop, if you just double click on the box itself, it'll open up the properties for the e-stop function. So I want to change this from a single channel to a 2-channel. And now I want to assign the actual input connections for those 2 channels. So if I come and open this up, and I'm going to do it from the 3SK2 base unit, you notice here's those terminal identifiers, making it a whole lot easier for me to know which one to choose. So if I double click on channel 1, you notice it will automatically fill in 1 and 2. Now this had to be a monitored start because it is an e-stop, and so by code you have to have a manual reset function. So I'm going to change this to monitored start, and now click OK. So now you'll see here's the 2 inputs have been assigned, but I don't have an input assigned yet for the reset function or the start function. So to handle that, I'm going to come back over to my right-hand tree and open up cell functions and come and grab an input cell and drag that here. And then I can just connect the dots between that and the start. The reason why they ask you to come in and wire that separately is there could be a whole lot more logic in place going to that start function rather than just a single cell. So in our case, it is just a single cell, and now I want to assign that reset button to perform that task. So if I double click on the input cell, here where it says not connected, just like before, I expand this open, and I slide down for the input that's been assigned for the reset push button, which is input 11, and click OK. So now I have the logic for the e-stop portion of the system. Now I want to do the safe output. So if I come over to the right-hand column under output functions, switching output, and now I'm going to do a fail-safe output. So I'm going to drag that into my tree. And again, open properties, you double click on it. And now this is going to be a redundant output. And now I'm going to assign 2 outputs to it. The M1 fast and a second one that we called M1 slow. And what that is actually that spinner has the ability to spin at a fast rate or a slow rate, so that on some example applications where we wanted to do a delayed stop, we would actually be able to show the spinner in a slower motion when you go into a delayed stop. That's the reason for the fast and slow. So now we click OK. And now all we have to do is connect the dots between the output of the e-stop and the input of the safe output. So now our logic is complete. So the next step is to download this configuration into our safety relay. So what I want to do is I want to come in first and save it. And I've called this project exercise 1. So I'm going to click the save button. And now I'm going to click the download. So now I'm going to pick what COM port I'm working on, which is COM3. And now I'll go and download it to the device. Now after the completion of the download, what you'll see down in this lower right hand corner, where we're offline. After the download, the software is configured to go to online mode. Now that is a setting in the software. You could set it so after you're finished downloading that you would stay in the offline mode. But for this purposes, we go straight to the online mode because of the next step is easier for us. And what that step is to go into a test mode to be able to test our logic. So we'll come in. Do you want to activate the test mode? Yes. There's been a password that's been assigned to this safety relay. So I'm going to type in that password. And now you'll see that it'll change the operation now to a run condition and test mode. So now I'm going to show you with the video of how this is working in real. So here we are with the video. So here again is the 3SK2 base unit, and I have my e-stop on top. And so the logic was if the e-stop is released, which it is right now, and if I press and release the blue button, that will activate that output, and now my spinner is spinning. And if I press the e-stop, it shuts off. And if I reset it, it starts back up again. And you'll notice on the front face of the relay, it actually, if you can see close enough, it actually says the word test. And that allows you to do some quick testing of your safety circuit while you're still developing your code. The test function only lasts for as long as the software is open or for as long as that serial cable, which is plugged in here, is connected to the system. So now we're going to move on to the second exercise where we're going to add the RFID gate switch in an additional logic function. So now let's move on to exercise 2. So before I want to add any software configuration to this original one, I need to go back offline. So I'm going to come up here and click offline. And do I want to adopt the online view? No, I want to keep the view for my offline project. Again, I have to enter in the password to get out of test mode. And so now I want to add that protective door. So I come on the right-hand side and choose protective door and drag that over into my project. And again, this one is going to be a 2-channel. So I'll change it from a single channel to 2-channel, both normally closed. And now on the input, we'll go find the RFID switch. Here it is, channel 1 and 2. So here's my 2 inputs for that RFID switch. And this one is going to stay automatic because this on a door, by code, you could have the machine automatically start back up if that door closes. So we're going to click OK. Now what we're going to do is we want to have both the e-stop and the protective door basically in series to shut off this output. And the way we're going to do that is by putting an AND function between them. So I'm going to come over here to logic operations, and I'm going to drop in an AND statement. So now what I can do is disconnect the connection between those two, and now I'm going to connect the e-stop as input 1 and the protective door as input 2, and now the output will go up to that output there. So now we've added in a protective door. So now if either the e-stop or the protective door opens up, it'll shut off that motor. So we're going to go and save the project again for exercise. Now we're going to do it as exercise 1 and 2. And now that it's saved, we're going to download. And again, once it finishes downloading, it'll come in and finish in an online state. And once we're online, now we can go back into test mode again. So we'll go to target system, test mode. Do I want to go into test mode for sure? Yes. Re-enter that password again, be in a safety system. That's a requirement. And again, now we're just now back in test mode and we're running, and we'll show you again now the operation with the additional door function. So once again, here you can see we're test mode again, and the spinner's not running yet. The door is closed. The e-stop is released. So now if I press and release my start button, you can see the spinner starts to go. And if I open up my RFID switch, it stops. And if I closes, it has the automatic restart function. However, if I hit the e-stop and shuts off, once again I have to have the manual reset. So just that quick, I was able to expand my safety logic for this first zone of control. So now we're going to move on to exercise 3, where we're going to add a second zone output. And that's really the strength of a programmable safety relay, is to do multiple zones on your output side. It's nice to be able to change the software easy for a single zone, but when you have multiple zones is really the strength of the 3SK2 series. So now we'll go to exercise 3, where we're going to add the interlock switch. So now let's get started for exercise 3. Again, this is where we're going to add an additional protective door for that interlock switch. So I've already gone offline, so I can come up here and click on protective door and bring another protective door function in. Again, I'm going to change the properties for that to be a 2-channel to get the higher safety rating. And now come in and grab the 2 inputs for the position switch. And this is also going to be an automatic restart. So we'll click OK there. So now the next thing we want to do is we're going to do the F output and bring that in. Now this time, because it's going to be the 3RM1 hybrid starter as an output expansion card, we're going to leave this as a single F output, even though it is rated at a SIL 3 setting because of the internal redundancies of that failsafe starter. So on my connection for Q1, I'm going to come in, excuse me, and now select 3RM1F motor starter. Click OK. Now what I want to do is, in addition to turning off the motor starter for the protective door, I want to add an additional AND statement with the e-stop function. So I'm going to come in here and grab another and drop that here in the middle. And now the output of the second protective door goes to input 2, and then the output of that e-stop is going to come back down here to input 1. So what that allows us to do is, again, we'll have 2 zones of control, but now the e-stop becomes an area e-stop that will shut off both outputs if the e-stop is pressed. So that completes our logic for exercise 3. So the next step is to save it. So we'll come in here and do save as. And now it's going to be exercise 1, 2, and 3. And now we'll go download that. Again, after we finish downloading, it'll go into online mode. And we'll go test our circuit again. So as it transitions back to online mode, we come up here to target system, test mode, enter the password. Switches to test mode. And now we'll switch to the video to show you our working demo. So here we are back at the demo, and the e-stop is released. So now I'm waiting on a reset to start the system up. Now, what I want you to show first is on the 3RM1 starter, it may be a little bit hard to see in the video, but there's no LEDs on, which indicates the output is not on yet. So if I come in and hit the reset button, you notice the spinner starts spinning, but now I have a green LED. That means the starter has been enabled in regards to the safety circuit. And now what it's waiting on is an actual start command from the regular control system. And what we've done is we've wired a 3-position selector switch to provide those start commands. So if I want to go in the left direction, I spin that switch and you see now the spinner is going in one direction. I can stop it. And now I go in the opposite direction. So just think about this starter is not only a fail-safe starter, it's a fail-safe reversing starter capable of switching a motor up to 6 amps in capacity in a very small footprint, and it's an integrated part of our safety relay system. Everybody else's system would not be integrated into the safety relay itself. You'd have extra wiring out to the starters for their solution. And again, if you open up the RFID switch, it'll stop motor 1 and have the automatic reset. And if I pull the interlock out, I stop motor number 2. But it starts back up automatically. And if I hit the e-stop, it now shuts off both outputs in an area e-stop function. So just that easy, we've configured 3 different exercises that have built on top of each other and have been able to quickly test the circuits. Now what we're going to do is show you how to finalize the configuration and certify it as a safety system. So we're back in the Safety ES software, and the last step, now that we've finalized our configuration, we want to go and approve it as our final design. So the way we do that is you go offline, and now I come up to Target System, and I want to approve the configuration. Now I have to go back online in the software temporarily. What it does is it's going to create a link to say, is the online project that's in the safety relay matching the offline project that's in my computer right now? And since it does match, I can release it. And when it does that, it now will ask you, as the certifying safety engineer, to be able to document it. So you're going to put in your name and the company that you work for. Now what you want to notice is this CRC code. This is a unique hex code that is generated every time a configuration is approved. So once you ship your machine as an OEM, this is your proof of how the machine was shipped. If later on, say, an accident was to occur and they go look at that safety relay and this CRC code is different, that's proof that someone has changed this configuration from the time it left your original design. So come in here and click OK. It was successfully released. And now this PDF document becomes part of your proof documentation. And with this, you'll ship this with your machine and you'll keep it a copy for yourself moving forward. So we're going to close that down for right now. And now the last step is to put the system into run mode. So I do that by coming in here and going back online. And once I'm back online, instead of going to test mode, because the system has now been released, I can go to a full safety mode. One more check. And now you'll see it'll switch to a safety mode, but now it's in full run mode. The difference between test mode and run mode is with test mode, it's only in test mode for as long as your computer is still connected to that safety relay and or that serial cable. If you turn power off of the relay or unplug that serial cable, test mode is canceled. Where safety mode is now locked in. So I could go in and unplug my serial cable or even power down the safety relay. When it powers back up, it'll be in full run and protective mode again. So now we'll turn back to the camera and show you the final configuration in run mode. So here we are back with the live camera, and if you can see now the indication on the safety relay, it's now in full run mode. And so just like before, if I come in and reset the system, which I'll have to reset the e-stop first, notice both are now running because I'm in the operation, and again, separate zones for each of the door switches. And the e-stop is a full area e-stop for both zones. The last thing I want to show you is one of the latest developments for the 3SK2 safety relay family. And that is the additional communication capability. And so now the 3SK2 safety relay also supports Profinet connectivity. So now I can drop in an additional hardware card as a Profinet interface. And that's what I have up here on top of my demo. If I double click on the card, I can come in here and assign, say, an IP address for it. And now I can download that configuration into the device. So again, we have to save our folder. So I can click Save. Now when I change the configuration like this, it will cancel that release configuration that we just did to put the safety relay into a run mode. So after we download this, and now that we have a Profinet card, you can actually download through the interface if you want. We'll still go through the local interface. So now it's finished downloading. And again, once we finish downloading, it'll finish in online mode. If I want to re-release the configuration, that you have to do from an offline configuration, offline connection. So what I want to do here is, again, go offline and say no, so that now what's online is matching what's on the screen offline. And now I can come in here to target system, approve my configuration again. Again, I'll use the serial connection. And again, this is where they're going to match what's online versus what's offline. Go in and put our name and company in again. Now you'll regenerate a new document. You'll see now it's a new CRC code. And again, this is the document that you want to be able to keep as an OEM for proof of what your configuration was at the time that left your facility. This will become a legal document somewhere down the road if in turn, if you ever pulled into a court of law based on an accident. So we'll close that off. And now that we've released it, we're going to go back online. And we'll put the unit back into run mode. Once we're back online. So now we come up here to target system and put it back into safety mode. And now we're still back in run with the original configurations from our exercises 1, 2, and 3. But now we have this additional card. Now with our demo, we didn't have space on the left side of the 3SK2 module to put the Profinet card, so we just wired it external to the demo, but wanted to show it to you anyways. So with this Profinet card, you cannot send safe signals up to the PLC, but what you can do is status signals. Again, it's not a safe connection between the PLC and the safety relay. It's really more for diagnostic and monitoring purposes. The next thing I'd like to show you is some of the diagnostic capabilities that you also have with the Safety ES software. So while we're online here, I can actually come up to this top toolbar and click on a button showing the eyeglasses and the logic. And what you do is you go online now and look at the operational of the different switches. So say on the e-stop right now, everything is green on the inputs. If I press down the e-stop, you notice that these will go white, showing that they're open. On the RFID key switch, if I slide it open, you can see those go white. And the same thing on the interlocking switch. If I pull out the key, those open those inputs. So now I reset everything ready to go. And if I go and press the reset button, you can see now everything is green and both outputs are on the zones. If I open up the RFID switch, you'll see that the output goes off. The e-stop is still happy. So if I close it, it automatically restarts. And the same thing with the interlock switch. If I pull it off, that one zone shuts off, independent from the other. And if I put the key back in, it goes back operational. So again, the software itself can be a very good diagnostic and commissioning tool as well. So here are the last few items that I wanted to finish up with. The first one is another software package, which is a full simulation tool that is now available for the 3SK2 family as well. It is free of charge, downloadable from our support site. And you can go in and either open up a project that you've already configured and do simulation testing on it, or start a project from scratch with this tool. We also have manuals for both the 3SK2 safety relays, the whole family, as well as a manual for the Safety ES software. And we have a general safety integrated application manual, which is very good. It's full of all different good topics for safety, including definitions of some of the common safety terms, as well as sample application, sample circuits for different safety configurations. And it's also free of charge with a download off of the Service and Support website. So with that, I'd like to thank you for attending today. Once again, my name is John Burns, an application consultant for the Electrical Products Group here at Siemens. If you'd like to get more information about the control products or the safety relays, please visit us at www.usa.siemens.com/controls. Thanks for watching.
Siemens, ingenuity for life.